Welcome back to Business Mathematics 1. I'm Eric from Mathematics Study Program, Faculty of Mathematics and Natural Sciences, ITB. So for today, we'll continue about exponential and logarithm function for the special focus on the logarithm function. Let's start. So logarithm is defined as the inverse of the exponent function. So I can imagine like this. Don't forget, if you have maybe y equals 2x plus 3, how do I find the inverse? Okay, yeah, I just have to switch y and x. I want to find x as a function of y. Okay, yeah. That is, how do I find this? This is the same as 2x equals y minus 3. So x equal my minus 3 divided by 2. What about if I have 2 to the x is y, 2 to the x is y. So I want to have x as a function of y. And this function of y we usually call log with base 2. Okay, yeah. So this is just inverse function. So if I want to find 2 to the x is y, 2 to the x is y. So if I want to find what is x, what is the exponent here? So the exponent here is given by logarithm of y with base 2. Okay, yeah. So this is just inverse. Okay. So if x is real positive, the logarithm of x with base b greater than 0, b is not 1, is written by log x with base b. That is the value y such that b to the y is equals to x. So we want to find what is log 1 with the base 2. Is the same as finding 2 to the power of y equals 1. So what is y? Y should be 0. So log 1 with the base 2 is 0. What about log 2 with the base of 2? So I can bring this to the exponential function. It will give you 2 to the power of y. If we let this equals y, 2 to the power of y is equal to y. So y should be 1. Okay, the same if I have 2 to the power of 3 is 8. So I have in logarithm 3 is log 8 with base 2. Okay, yeah. So this is just a relation inverse between exponent and logarithm. And that's why the base is the same. Positive and not 0, not 1. Okay, yeah. Now, let's continue. Now this is the properties of logarithm. If I have the base is satisfy this and u and v is a real positive number, so when the logarithm of u equals the logarithm of v is when u equals v. But this is for the same base, yeah. This is all for the same base. What about the multiplication of u times v? So it is equals the log u plus log v. This is just the same as this. Don't forget, what is this? This is the exponent of the multiplication with the same b base. So this is, I can look at this like this. Sorry. So if I have log b of u times v, this is the same as log b u plus log v with the base b. This is the same as b to the x times b to the y equals b to the x plus y. Don't forget, when we are talking about this, what is this? I have a multiplication with base b. Multiplication with base b. Okay, yeah? This is u, this is v. So if I have multiplication with base b, what is the connection between the exponent of this? So the exponent of multiplication is the addition. So this is just the addition of the exponent. This is, don't forget, this is just the exponent. This is just the exponent. This is the sum of exponent. Okay, so the exponent of the multiplication with base b is equals to the exponent of u and the exponent of v with base b. Okay, the sum of the exponent. Okay, so this is just the same rule. This is just the same rule, but it is formulated with different language. That is, this is for exponentiation, this is for logarithm, and you can do the same thing for the division and multiplication. Okay, yeah, multiplication. And for us, the same reason, we have a special logarithm function. That is logarithm with the base e. When I have logarithm with base e, we usually denote this by ln. Ln is natural logarithm of x. Log x, we usually write this ln, natural logarithm with of x with base e, 2.7 and so on. Okay, this is the graph of a logarithm function. Okay, first of all, this is, don't forget, if I have logarithm is the inverse of exponent function, fgx should be x. This is not, this is okay, yeah, because if I have, okay, yeah, this is maybe d, maybe dr. So if I have this x, this is as x, this is f, okay, yeah, this is x, you can get this y equals fx. I can get the inverse. The inverse is g. If I have x, fx, the inverse of this should give you x also. So fx inverse of fx should give you x. From x with f with g should bring you back to x. The same if I have this, let's say that this is okay, yeah. Let's say that I have this, I have this, okay, yeah. And I have this is, oh sorry, this is x, this is fx, okay, yeah. This is g, this is f. So if I have g, maybe okay, I have g, then f, it should be the same number. So I have this one. F of gx should be x and g of fx should be x because they are inverse function. Okay, what is f is ln x, gx is e to the x. I can do the same thing for an logarithm with base other than e, that is log x with base b. B to the x is just the same, but I want to have with the natural logarithm. So ln of e to the x is x and e to the ln x is x. Okay, and what about the graph? Don't forget, this is the graph y equals b to the x. I want to find the inverse and I have to switch x and y. So I have to switch this x and y. What happened when I switch this? This is the same as reflecting it with respect to the line y equals x. So if y equals b to the x is this, the inverse is I have to reflect this with respect to the line y equals x. So I have this one. If the exponential function b to the x always have y-intercept, that is 0, 1, for the logarithm function, it always have x-intercept, that is 1, 0. It makes sense, yeah, because you have this reflected with respect to y equals x. Okay, so this is and this is the relation between the base. So if you want to find this is a logarithm with base b, I want to change it with base c. This is the relation. Logarithm x with base b is equal logarithm x divided by logarithm b with another base, that is c. Okay, yeah. In high school we usually have this one. Log c with respect to x is the multiplication of this one. Okay, yeah. In if I want to look at how I change from the b base b to base e, this is the formula. Okay, and if I want to find the derivative of this, I can look this to the exponential function, that is this. I can use implicit differentiation, so I have e to the y times dy dx equals 1, this one. And what is e to the y? E to the y is x, so I have dy dx is 1 over x. So the derivative of ln x is 1 over x. Okay, yeah? And you can find of this, what is the derivative of this? Very easy, yeah? 1 over 5x times the derivative of 5x with respect to x, that is 5. What about the derivative of this? 1 of this with times the derivative of this with respect to t. Okay, yeah, so this is the property of logarithm. Don't forget this is b to the x, and this is and logarithm x with base b. Yeah, here b is from 0 and 1. For greater than 1. For b from 0 and 1, you have this kind, yeah, decreasing. So you have the logarithm is just this, decreasing also. Okay, yeah. But this is the picture when b is greater than 1. Okay, so the logarithm function fx equal log x with base b. B is greater than 0 and b is not 1. It is divine and continuous for all x. Okay, yeah, for all x positive. Negative, no, because we are just reflecting it with y to the x, y equals x. So the y-axis is the vertical asymptote. This is the vertical asymptote. When x goes to 0, it goes closer to minus infinity. Okay, when b is greater than 1, this one. So when x goes to 0 plus, it will goes to minus infinity. And for x goes to infinity, it will goes to infinity also. You can check for b from 0 to 1, yeah, by just looking for b to the x when b is 0 to 1. That is this one. And reflecting to this, you have this as your logarithm. Okay, yeah? And for all x greater than 0, the function is increasing for b greater than 1. Okay, yeah? For b from 0 to 1, it is a decreasing function. You can just check. Now, this is the application of logarithm. So someone invests 100, interest rate is 12% PA, compounded monthly. In how many years will the accumulated amount reach 150? So this is the formula for the compound interest, the accumulated 150, and the principal is 100. Interest rate is 0.02. Compounded monthly, so this should be 12, and this is 12t. I want to find how many years does it take to make from 100 to 150. So I have this. How do I find the exponent? Logarithm. So I have a natural logarithm here and natural logarithm here, and I have a logarithm of this. The exponentiation become multiplication. So 12t times this. So t should be this divided by 12 but divided by this. Okay, so I have this. So in 12.3 years, your investment 100 will become 150. Don't forget this is just a one-time investment. Okay, yeah. Okay, try reading about half-life in the textbook. So, today we have talked about the logarithm function and its properties for the logarithm function and the application of logarithm function. So, for the next meeting, for the next discussion, we will discuss about the derivative of exponent and logarithm and its application. Okay, thank you very much.